G'day guys, and welcome back to another Further 101 lesson. My name is Jake, and today we'll look at how categorical data can be displayed and analysed. This is the first video in the Univariate Data sub-series, which is part of the core module series on data analytics. As always, use the timestamps in the description below to navigate this video. Now before we jump in, let's do a quick refresher on categorical variables. Categorical variables contain data that describes the quality or characteristics of the thing being recorded. Think of variables such as the colours of cars passing by, or the gender that a person identifies with, or even the town that a person lives in. Categorical variables therefore organise or label whatever is being observed or recorded into categories, hence its name. There are two subtypes of categorical variables. If the different categories inside a categorical variable have some implied or logical order of presentation, it is defined as an ordinal variable. Now, a typical ordinal variable is the response to a survey question which has one of 5 possible answers in strongly disagree, disagree, neither agree nor disagree, agree, or strongly agree. Notice how it always seems logical to present strongly disagree first and strongly agree last, or vice versa, with the other answers ordered correctly in between. The data should be presented in this order to make analysis easier and clearer. If there does not appear to be a logical order to the different categories, the variable is defined as a nominal variable. It is usually fine just to call these variables by their broader definition as a categorical variable, rather than specify it as a nominal variable. Perhaps the easiest and simplest way to organise any type of data, including categorical data, is with a frequency table. In fact, it's typically the first thing completed when working with data. There are typically 3 sections to a frequency table for a single categorical variable, as represented by each of the columns. The first column is the name of the categorical variable, with all of the unique categories listed down the column. This categorical ordinal variable in the table indicates how many times a person cooks in a year, with 5 general categories: never cooks, rarely cooks, sometimes cooks, often cooks, and always cooks. The second column is a tally of the responses to each of the categories. Do note that this column is optional and often not displayed in the final exams. However, it is useful to complete a tally yourself if the data is not already organised and counted in a table, but just listed as raw data in rows. The final column provides the frequency of each category. That is, it indicates how many times a response for each unique category was recorded. Frequency can be in one of 2 forms. A count gives the actual number of times each category was recorded, whereas a percentage gives the percentage of records for each category, given the total number of responses recorded. Sometimes both the count and the percentage are given, but usually only one is provided. That means you will be expected to convert an answer to the other frequency type if required by the question. At the bottom of the frequency table is a table row. This may not always be provided, however it is extremely important that you count the total of the frequency column, even if the total is provided in the question information beforehand. This not only allows you to check that you have completed the frequency table correctly, but also provides valuable information that will almost certainly be used in later analysis. Do note that sometimes the total of a percentage frequency column may be a couple of decimal places off from the expected 100%. Typically you might see answers of 99.9% or 100.1%. This is usually a rounding error, as the frequency percentages are typically only written down to 1 decimal place. Don't fret if you are only off by a tiny amount, it's probably a rounding error. However, if you are off by a little bit more, chances are you've made a working error, and you should double check your working to make sure it's correct. To make things even trickier, students may be asked a question where they have to provide a frequency answer that is the opposite to the type of frequency provided in the frequency table. For example, you may be asked to provide the percentage of persons who sometimes cook, even though the table here only provides accounts of people who sometimes cook. Too often, students skim the question and incorrectly assume no frequency conversion is required. That is, students write down their answer as a count of a category when the question specifically asks for a percentage, or vice versa. To avoid this easily made mistake, make sure you know what frequency type is provided in the table, and double check the type of frequency being asked in the question before answering. Complete a conversion from one frequency type to another if needed. Let's quickly go through how to do a conversion now. If you want to convert a count to a percentage, divide the count number of the relevant category by the total count for the whole categorical variable and multiply it by 100. If you want to convert a percentage to a count, divide the category percentage value by 100 and then multiply by the total count for the whole categorical variable. Whilst frequency tables are quick and easy to create, and often the very first thing done when sorting with data, they can become messy and fairly hard to interpret. To make categorical data more visually appealing and hence easier to analyse, we often turn to our trusty bar chart. There are a few key rules to understand when drawing any bar chart. The first is that the x-axis or that horizontal axis is where all the unique categories for the variable are placed and should be labelled accordingly. The second is that the y-axis or the vertical axis indicates the frequency, either in count or percentage. It should be labelled frequency or percentage accordingly. And last, there is one bar per unique category, and the bars must be separated, indicating that each unique category is just that, a unique separate category. Here we have an individual bar for each of the response types from never through to always. Bar charts make it quick and easy to see which category has more or less responses recorded, given the relative heights of each of the columns or bars. For example, it is clear that far more people rarely cooked compared to those who never cooked. As with frequency tables, you will often be asked to provide an answer as a count when the bar chart displays a percentage frequency, or vice versa. Ensure you know what frequency type is used on the y-axis. Then check what frequency type was asked of you in the question, and complete a frequency type conversion if the answer requires it. For the most part, you will be asked to analyse bar charts and other graph types rather than draw them. So let's go through some question types now. The first question is a true or false, and as the name implies, true or false questions will ask you to confirm if the statement provided is true or false, given the information provided in the graph. Now this first question says, more persons cook sometimes than the people who never cook and rarely cook collectively. Is this true or false? Well, let's go through each of the steps and break it down. Now the very first thing to do is to check how many people sometimes cooked. Now I should say that even though there are percentages on this graph, the percentages are all related to the one total, and so we are able to compare the percentages without too much hassle. We can see here that 40% sometimes cooked from the total of people that were analysed. The next step is to look at the sum of people who never cooked and rarely cooked. And if we add those percentages together, we'll get 30%. Clearly more people sometimes cooked than never and rarely cooked, so this statement would be true. Provide the frequency questions ask you to do just that. Write down the frequency of the category or categories that are asked of. As with any question regarding frequency, don't forget to double check the frequency type used in the bar chart and ask for in the question, and complete a frequency type conversion if necessary. Here, the question asks us to provide the percentage of persons who said they often cooked. However, the y-axis provides the count. Now if you recall, but go back to our count to percentage formula, we have to take the count, divide it by the total persons from the whole data set, and multiply it by 100. Well, we know that the count for people who offset they often cooked was 6, and we can calculate a total by adding up all of the bars together, and here we get 30. Now we just put these numbers into our formula, and we can see that 20% of persons responded that they often cooked. Category total questions ask us to provide the total count for the entire categorical variable, although this typically only occurs when the y-axis frequency type is a count. This can be calculated from the frequency table or by adding up the bars on a frequency bar chart, not a percentage chart again. We already calculated this in the previous question type, so I've thrown a little twist to this question. Here the question asks how many persons have cooked at some point in their house. Now, most people would quickly jump into this and just add up all the bars. But you need to take account of the wording of this question. It asks for how many people have cooked at some point, and yet one of our categories is people who have never cooked. So they really wouldn't fall into this cooked at some point total. So we actually need to scratch that first value, and we can see that our cooking total is 29 persons. Our fourth question type is for the modal category. Now the mode is one of 3 of the types of measurements of sensor, and essentially means the most frequently occurring category. Hence, this question asks which category has the tallest bar. Clearly by looking at our graph, we can see that the modal class is sometimes, as most people responded sometimes than with any other of the category types. As an alternative to the bar chart, which depicts each category as a separate bar, each of the categories may be stacked into one bar. Each section of the stacked bar is coloured or patterned differently to represent different categories. Again, the y-axis or the vertical axis can represent either a count frequency or a percentage frequency. Too often, students incorrectly think that the value corresponding to the top of a coloured section on the bar is the frequency for that coloured section's category only. For example, students may think that the count for sometimes is 21. However, this gives the frequency not only for that category, but also for all the categories stacked below it, and therefore would be incorrect. Whenever you are asked an analysis question for a category, you must calculate the difference between the value at the top of the coloured section and the value of the bottom of the coloured section for the appropriate category. For example, calculating the number of persons who stated that they sometimes cook is correctly calculated by subtracting 9 from 21, as there are 2 values at either end of the pink section. This gives us the answer 12, just like we calculated before on the frequency table. You may be wondering what's the point of stacking the categories into one bar, other than saving a bit of space on paper. Well, its purpose is fully realised when working with 2 categorical variables. Each individual bar represents one category, whilst the coloured segments represent the second category. Take a look at this example. There are 2 categorical variables here. Age is represented by each individual bar, whilst cooking frequency is represented by the segments of each bar, as indicated by the graph key. However, don't worry about this just yet. This will be further explored in the bivariate section of the core module series. So now that we've been through the theory, let's go through a practice question. We've got this hypothetical scenario where Zoe owns a clothing store and wants to analyse the sales on last month's shirts given all the sizes that she sells. Take the time to pause the video, go through the question, and then hit play again to check your answers against mine. So the first question wanted us to look at what type of variable are we dealing with here. Now the shirt sizes here are displayed from extra small to extra large in each of these individual categories. And there's clearly an order from extra small to extra large. We would always present them in that order. So this is a categorical ordinal variable. The second question wanted us to fill in the gaps in the frequency table. Now I've done these here in blue, but we'll go through each of them and see just how I calculated them. Let's start with calculating the percentage for extra small sizes. Now to do that, we'll use our count to percentage formula, where we're going to take the count for extra small, divide that by the total of shirts that were sold for last month, and multiply that by 100. Now we of course sold 2 shirts, and we have 40 shirts in total across last month's sales for this shirt, and from there we're going to get 5%. It's the same thing for calculating the percentage for extra large. We had 1 sale of an extra large shirt, and we've divided that by the total of sales for shirts, which was 40, and here we're going to get 2.5%. But now let's calculate the counts for medium. Now that's a slightly different formula to calculate the count, where we're going to take the percentage that's given for medium sales, divide that by 100, and multiply that by the total sale of shirts for that last month. So we take our 40%, we divide that by 100, and multiply that by 40 shirts, and we can see that we sold 16 shirts in the medium size. We'll do the same thing for large as well. We had 6 shirts sold in the large size, and we calculated that by taking the 15%, dividing it by 100, and multiplying that by the 40 shirts sold in total. Question 3 asked us to draw a bar chart, and I've put it here on the right. Now do make sure that you've put frequency in the y-axis and not percentage, because that's what the question asks for. If your graph looks something like this, you're doing pretty good. The 4th question asked how many large shirts were sold last month. Now in fact we calculated this in the previous question, but we can also read it off the graph here, and we can clearly see that there were 6 shirts sold in the large size. The 5th question asks what percentage of sales were for extra small and extra large shirts. So we actually need to add the percentages for both the extra small and extra large. We'll get that off the frequency table, and we can see we had 5% for extra small and 2.5% for extra large. In fact, we calculated both of those, and that gives us an answer of 7.5%. And the last question asks what was the most popular size sold. In essence, this is asking us what was the modal class. And we can see that was the medium shirt. Zoe sold most shirts in the medium size. Thank you so much for watching my video, guys. I hope you enjoyed it, and I hope it taught you something. Thank you so much for watching another video from Further 101. I hope it gave a bit of an insight into how to work with categorical variables. Don't forget to subscribe to our YouTube channel, and you can find us on Facebook. And whilst you're here, why not explore a couple of other videos? Thank you so much for watching this Further 101 video on categorical variables. I hope you all took something out of it. Whilst you're here, why not subscribe to our YouTube channel and check out our Facebook page so you can keep up to date with all of our latest updates. That's all from Further 101.